Page 94.
So good. Yeah, but what? What?
Yes, page 94. There we go. Okay, so what is an ion? An ion is an atom or group of atoms with an electrical charge. So that's different. Atoms, do you remember atoms are neutral? But if we take an atom and we give it a charge, either positive or negative, it stops being a plain old atom and it becomes an ion. And the charge could either be positive or negative. Pardon me? I am not hearing you because I heard gang supars, which is absolutely not what you said. Superpowers, yes. They gain superpowers, yes, they do. Yeah. Okay, so let's go back to Tyler here. Oh, once you finished writing.
Oh, yeah, we're doing presentations for that. I personally keep wow, dude, yeah, that's really cool.
If you don't succeed with that one, Kai, I've got like pencil sharpeners up here that generally work better.
You're not sick.
There you go.
You know, it probably looking for light. On the signal on the signal, live signals.
What did he leave out of this model? The neutrons, okay? Because they don't matter, because they don't have a positive or negative charge, so they don't affect whether it's going to be positive or negative. Okay, so you're going to fill that in. The net overall charge is 0. Okay, so net means overall. Have you heard of a net profit? Okay, so like if you spend $100 on your business, but you get back 150, your net profit would be 50. So the net charge is like the overall charge. Okay, so you're going to fill in neutral. Okay, neutral means no charge. Okay, so you're going to fill in the box that says loses. Okay, so above the arrow, fill in loses.
Yes.
Now here's the puzzle for you. What is the net or overall charge for this structure now? It's no longer 0.
It would be 1.
It would be 1. Would it be 1 positive or 1 negative?
Positive.
Well, positive.
Negative will throw more electrons and protons.
Yeah, because we've got more positives than negative, it's going to be a positive charge. And because we only have 1 more positive than negative, it will be plus 1.
Yes.
Okay, so I'm going to get rid of the subtitles. And for the symbol, the box that says symbol, for this one that's neutral, you're going to write NA. And this one that is +1, you're going to write NA plus. If we write plus without a number, it means +1. If we write 2 plus, that means there's 2 positive charges. Okay? We'll get to that later. You can also write +2. I know that messes with people's head, but it's okay. Now, just before we move on, yes. Just before we move on, I wanted to do something here. Okay, it's not behaving. There we go. All right. There are 2 ways to figure out the charge. 2 ways to figure out the charge. The first one is to say, I have 11 positive things and I have 10 negative things. And when I add those together, I get 1 positive. Yes?
Yes.
Okay. The other way to do it is to say, I am losing an electron. So I am losing a negative thing. I am losing 1 negative thing. And if I subtract -1, what do I get?
Positive
1.
one.
So that's the other way to figure out the charge. If you lose a negative, you become positive. What if you lost 2 electrons? What would your charge be?
Positive.
+2. Okay? We'll go through a whole bunch of these, so don't worry if you didn't quite catch that. It's okay. All right? And just so you know, I know he just said it, but this is not cation, it's cation. Cation. Okay, cation.
Cation.
So fill in the net charge in that oval. Fill that in. Okay, fill that 0 in the oval.
0.
And what means no charge?
Charge out.
Neutral means no charge. Okay, so above the arrow, you're going to write gains 2. Above the arrow, write gains 2. Okay? All right, so now you get to figure out what the net charge, the overall charge of this ion is. And remember, there's 2 ways to do it. You can either add up the protons and electrons, giving the electrons a negative. Yes. Or you can say, I'm gaining 2 negative things. What's the charge? -2. Okay, so we can fill in our symbol. Actually, why don't I do it here?
No, she didn't like that. He said it's not cool to make fun of him for not making it go wrong.
So this gains
He said,
2 electrons. Overall charge is 0. -2. Neutral. The symbol is O. Now, I'd like you to take notice of this. When Tyler wrote this, he didn't write -2, he wrote 2 negative. That's the official chemistry way of writing the charge, is to put the number first and then the sign. For this year, though, because you're only in grade 9, if you write O -2, nobody's going to get mad at you. I certainly won't. If you write -2, that's okay. But be aware that as you progress, if you take chemistry 11, for example, you'll be expected to write O2-. It's up to you whether you care about learning that this year or not. So this is also okay for the grade 9. Also okay. Yes?
why does my Na+1?
Because it is just, again, it's one of those things in chemistry where we just write, if we just write plus, plus means +1. But if you were to write Na+1, that would also be okay. If you wrote Na1+, that would also be okay. But the real chemistry way of writing it is Na+.
But if it's Na+2, right?
If it's Na+2, you would write Na2+. The number comes before the sign. But if you wrote +2, I'd be okay with that. Yeah? So,
So if it's
up to you how worked up you want to get about how you write it. I don't care. Yes?
I just want to write.
So if it's negative, yeah, like let's say I just had -1. Let's say I had fluorine, which is -1, I would just write F-. And that would mean -1. But again, if you were to write F -1 or F1-, these would be okay. This one would be the best. Yeah? Okay, good questions. All right. And Tyler's going to tell us our last word here, but we might as well fill it in while we're here. Positive ions. What were positive ions called? Cat ions. Negative ions are called an ions. Okay?
Onions.
In fact, that's one of the ways that you can remember it. Now, we could have Tyler teach us the little mnemonic devices, but we don't have to. Do you want Tyler or do you want me?
I want.
You want Tyler? Okay, let's do Tyler.
Just kidding. I want.
Okay, here we go.
Lives. Oh.
Okay, so you can fill that in on page 95. An ion is an atom or a group of atoms with a charge.
So when I went over to Micah's house, like 2 days ago. Yeah. Okay, yeah, you just sitting there. And he's like, "Yo, Max, come down." And he was sitting in his chair with his yeah.
So you just can't move out.
Yeah, he's like completely immersed.
First words,
Bro, go push out. Wait, challenging you.
Oh, just write this down.
an atom
Atom.
or a group of atoms with a charge. Yes.
I don't know.
So beside neutral, you're going to write no charge.
Charge.
Okay, so you're going to fill in cation, positive ion, anion, negative ion. And Tyler's going to teach you one mnemonic device, that's a memory aid, okay, that helps you remember that anions are negative and cations are positive. And then I'm going to teach you another one that is about onions, because he doesn't do the onion one. Okay, anion,
Negative one. Wow. That's right.
A, negative, ion. Okay, anion, a negative ion. Now the other one, the one that Tyler doesn't teach, is that anion sounds like onion. And what do onions do? They make you cry. And crying is kind of negative, right? Especially if it's due to an onion. Sometimes you could cry tears of joy, but it's never pleasant to cry because you've got onion in your eye. Yes? Onions make you cry, which is negative. Okay, up to you. I don't care which one you use to remember it. Or if you just want to say, I can just remember, that's fine too. Okay? So either a negative ion or anion, onion, crying, negative. Okay, hold on. We're just gonna go back for a second. Okay, so cats.
Holy shit, there's no way Alex is watching the video. I gotta stop sneezing.
Have pause
Lucy. Wow. It's like on this. On the insane. Nonchalant out here. He tries to be nonchalant.
cats have pause, so cations are positive.
I'm so serious. Awesome. How?
The other way to remember this one, if you don't like that, is that cation, if you write it lowercase, has a positive sign in the middle of it. Yeah, the T looks like a positive sign. And while we're at it, we're just going to go and learn what a polyatomic ion is. Does anyone know what poly means? Yes, more than one. So if something is polyatomic, it means you have more than one polyatomic, more than one atom. Okay, so he's going to tell us about that. Okay, so we're just going to ignore the rest of this because it doesn't really say anything. But what we're going to do is we're going to go here and make sure with our polyatomic ions, that's a group of atoms with a charge. Now, what would that look like? Well, I might have in what sense?
Like the parts itself come together on the model?
Probably not exactly. Okay, I'm actually going to use Dalton's model for this because it makes life really easy. Okay, so if I use Dalton's model and I have a nitrogen atom with 4 hydrogens attached, this whole thing has a positive charge. And if I write plus, what does that mean? That means how much? 1 plus. Okay? And we would write the formula for this as N. That's a weird line. We would write it as N. And then H. And we say that we have 4 H's by writing a little number at the bottom. That says I have 4 H's. And then I would put the plus at the top. Okay? I could also have a carbon attached to an oxygen and an oxygen and an oxygen. And it would have a 2- charge. And we could write this. Could you guys guess what the formula is for that? See if you can tell your partner what the formula is for that carbon with 3 oxygens attached. You guys got it? What would this be? Yeah. Oxygen, how many oxygens? 3 oxygens. And in front of that, what am I going to put?
C.
C. So this is CO3,
CO3 negative.
and then 2 minus, or negative 2 is fine. Okay? So those are polyatomic ions.
Ask for what? What is Jay asking? Asking for water, like.
Yes. So what's the difference between an ion? He asked me for like my
What's the difference between an ion and a polyatomic ion? Okay, so
Oh,
polyatomic ions are a type of ion. Now, most of the ions that we will deal with in this unit are called monatomic ions.
I just remember thinking about paper. I remember it.
So mostly in this unit, we're dealing with monatomic ions. Do you guys know what mono means? If something is monochromatic, how many colors?
2.
No? If you go on a monorail, how many rails? No? Mono means 1. Okay, mono means 1. So if I say monatomic ion, I could have an oxygen atom with a 2 minus. You see how there's just 1 atom? I could have a sodium atom with a plus. Do you see how there's just 1 atom? 1 atom. Poly means many. So polyatomic ions, you can see are polyatomic ions. Poly means many, and I've got like 5 atoms stuck together. Or I've got 3 atoms stuck together. Yeah? Mono, or mono means 1. And you see how I've just got 1 atom, 1 atom? Does that make sense? Kai, did that answer your question? Yeah? Okay, cool. So in this unit, we're generally going to be talking about monatomic ions. So if I just say ion, I probably mean just 1 atom that has become an ion. Okay? And I think it would be nice if we had a short break. So we're going to go outside and go around the parking lot. Okay, let's go. Come on.
So fat.
Why so convenient? Get it? It's like chocolate eggs.
Meet you on the stairs.
On this big atom, and I'll have like
Keep going. Let's go. Outside, you don't get a break.
Asexual gentleman.
Yes. And if we get through chemistry faster, then you need to learn about them. Yes.
do I have to run?
I don't have to run. Basically, walk if you want. Yeah. Okay. Walking to this now. Sorry.
Yeah, I did it right there. In the open. Where you from the water? Oh. We made it. Did perfect.
Where? But I don't know. By itself. I'm gonna go. Can I go to the wash?
Yes.
Can I just go with her? Like,
No,
okay.
we're not supposed to. Okay, folks. We are now on page. Where are we?
Yeah, you guys all love me $2. Why are you spraying on me, really?
Page 96.
Can you stop feeding around?
I'm just gonna go my watch it.
No,
Yes.
Please.
you can do it after we've done this. Okay.
Joke's on you, I have watched.
Okay. So we're on page 96. And we're going to learn about things that are stable and unstable. I think most of you would know that if I stacked some bricks like this, that would be unstable. Yes? Have you guys heard about potential energy? Is that something you've heard of before or no? How many people have heard of potential energy? Okay, yeah, okay. Potential energy is stored energy. And if things are unstable, they have a lot of stored energy. On the other hand, if I stacked my bricks like on the right, like over here, that has a low potential energy. That is very stable. You're not going to have them falling down on you. Yes? If you have a ball at the top of a hill, is it stable at the top of the hill or unstable?
Unstable.
Unstable. So that is high potential energy. High potential energy. Now, I get tired of writing potential energy, so I'm going to start abbreviating it PE. If we have a ball at the bottom of the hill, is that stable or unstable?
Stable.
Stable.
Low potential.
Low potential energy. Which direction does nature want to go? Does nature want to go from unstable to stable or from stable to unstable? Which direction does nature go naturally?
Unstable to stable.
Unstable to stable. So that's the direction things go naturally. So if you can make a system more stable, that's what's going to happen. And this is going to become important because ions form because it makes the atoms more stable. Okay? Ions form because it makes the atoms more stable. So here we go. Let's just go through these really quickly. An ion is an atom or group of atoms with a net or overall what? Tell your partner. An ion is an atom
Charge.
or a group of atoms with a net or overall charge.
You're so free.
I really want to do that.
In a neutral atom, the number of protons and electrons are what? The same.
A sun.
In an ion, the number of protons and electrons are they the same?
Yeah.
Yes? They're unequal. They're different because that's how you end up with a positive or a negative charge. They are unequal. In other words, they are different. Why don't you grab your water? Okay. What charge do protons have?
Positive.
Positive. What charge do electrons have?
Negative.
Negative. If the number of protons and electrons are not equal, then the atom will have an overall positive or negative charge. We would call this type of particle an ion. Okay.
What happened?
Why do atoms form ions? Shh. It turns out that a filled outer shell is very stable. And remember, what does nature like to do? It likes to go towards stability. I know, that was quite impressive, wasn't it? Never mind. Atoms will gain or lose electrons in order to have this stable filled arrangement. The outer shell has a name. It is called the valence shell. That's a vocab word. Vocab. So what if we want to form an anion? Anions, if you have an atom with 5 or more valence electrons, that means 5 or more electrons in the outer shell.
Let's go.
So if we were to look at oxygen from earlier today, here's oxygen. How many electrons does oxygen have in its outer shell? It's got 1, 2, 3, 4, 5, 6. How many electrons does it take to fill the outer shell?
It takes 2 more.
2 more. So that full electron arrangement is very stable. So oxygen would really like to gain 2 electrons. It would really like to have an extra electron here and an extra electron here, and that would make it stable. Are we good with that?
Yes.
Okay. And if it were to gain 2 electrons, remember electrons are negative, what charge would it become? Negative. How many negative? 2 negative. Yeah? So if you have 5 or more, because remember 8 is full, 4 is halfway full. So if you're more than halfway full, so if you've got 5 or more electrons, you're more than half full. This atom is going to gain electrons in order to fill the shell. Okay? Atoms with 5 or more valence electrons, they are all nonmetals. That's something all nonmetals have in common. Their shells are half or more full. And anions are the tricky ones because when they become ions, they actually change their name. If I told you about salt, does anyone know the chemical name for salt? Yeah? Oh, I thought you had your hand up. Sorry. Salt? Sodium what? Sodium chloride. And you'll notice, what's the name of Cl? It's chlorine, right? But when we have it in a compound together with sodium, we call it sodium chloride. And that's because it has become an anion. So the anion, when a negative ion is formed, the ending of the name changes to ide. So instead of chlorine, you will have chloride. Instead of oxygen, you'll have oxide.
Instead of cyanide, cyanide.
Well, except that's not an element. Now, here's fluorine.
Isn't the sea technically a huge soup of fish?
There's fluorine. Fluorine's atomic number is 9. What does that tell us? That tells us that a fluorine atom has 9 protons. What else does it tell us? A fluorine atom, which is neutral, also has 9 electrons. So in our nucleus, we have 9 protons. You can see them right there. Okay, there's our 9 protons. And we've got 1, 2, you don't have to draw these in, 3, 4, 5, 6, 7, 8, 9 electrons. And we have 1 empty space. That room is not filled, yes? And remember, stable is a full shell. So what would we like? We would like for an electron to come in here and fill that empty spot. Yes? So now we have a filled shell, and this is stable. So that's why they form it, because they like to become stable. It's like the ball at the top of the hill wants to roll down the hill because then it's more stable. So as we go from here to here, we gain 1 electron.
It's just a problem. Right.
So we go from having 9 protons and 9 electrons, which has a 0 net charge. How would we write the symbol for that? Just the symbol for fluorine. F. Okay. Now remember, we have 9 positive things, and now we have 10 electrons. We have 10 negative things, and if we add those together, what do we get? 9 positive and 10 negative gives us 1 negative. You can also say, I am gaining 1 negative thing, so I've become 1 negative. So the symbol for fluorine then would be F. And how do we show a negative 1? What would we write?
1 negative.
You can either write 1 negative or you can just write negative. So either 1 negative or just negative. And it's no longer called fluorine. Now it is called fluoride. Okay? Let's try sulfur together, and then you can take home the last one to do on your own. Okay? Yeah, we have another one, right? Yes. Okay. Sulfur is atomic number 16. Okay. So we have 16 protons and 16 electrons. I'm really unhappy with this. Let's cross this one out here and put it up here. Okay? Because I would like those first 2 to be paired up. Yes? Yours are paired up. Oh, I have an old version. Okay, I fixed it for your version. Okay, good. I'm glad I fixed it for your version. I've got an old one on here. Now we have 16 protons, and this is an atom. What do we know about the charge of atoms? Atoms are, what's the charge of an atom? Neutral. That means it's 0. So if we have 16 protons, how many electrons? 16. And if we draw them out, you can see on the outer shell, I've got a hole right here. I've got an empty spot here and an empty spot here. So what we're going to do over on the other side is we're going to gain 2 electrons. And so we're going to draw an electron in here, and we're going to draw an extra electron in here. So far, so good? All right. And we're going, now instead of having 16 electrons, how many electrons do we have?
0.
No, how many electrons? We had 16, now we have 18, but we still have 16 protons. So our net charge, we gained 2 negative things, so our net charge is -2. So our symbol for sulfur is S. What is our symbol for the sulfur ion?
SU.
S, 2 minus. And instead of sulfur, we call it sulfide.
Wow.
Okay? So your homework is going to be to do the nitrogen atom on page 98.
Is this a big one?
Maybe it's just 0.5.
And also, if you have not done, where is it? Oh, if you've not done 2.4a, do 2.4a. Or no, sorry, 2.4b. Some of you have already done it. If you've already done it, that's fine. It's pages 81 to 83.
Where do you do that?
Yeah, the readings on 81 and then 82, 83 are like work. Or actually, I think the reading's 81, 82. So 98, 81, 83. Also, next day, we're going to finish up ions and then you're going to do a lot of practice. And while you're practicing, I'm going to check all your homework. So you might want to go through and make sure that you are up to date on your homework. Where can you find the homework? Teams. Is everyone able to access Teams now? Yes? Okay, good.
I reach it.
For sure. Yeah, absolutely. Now, do you just want to do like those things? Because you don't have to redo everything. You could just redo those. Yeah, you could just redo those 4. Yeah? Whenever you want. Do you want to take it with you?
Yes, I have to go.
Yeah.
I can't go to Fort. So.
Yeah, no, just take it with you. Bring it back. Okay? Yeah.
Or talk to a shoe.
Max, was that you who jumped outside our window?
That was Jack.
Okay. It was very bizarre because all of a sudden a head popped up and I was like, that's quite a high jump. Anyway.
He grabbed something.
Oh, okay. That makes sense.
Jump off a chair.
That makes so much more sense now.
I really want to spray on top. I don't want to go to. Right?